Hello everyone. In this video we are going to discuss the numerical from your unit number 1, that is vector analysis, and this numerical is basically related with finding the divergence, gradient and curl of a given vector. Okay, so we are going to make use of all of the three properties within this numerical, and if you have any queries you can drop me a mail onto my this email ID. I will try to get you back as soon as possible. So now we will begin with what is given to us and what is to be done within this numerical. So in this numerical, we are given with some vector g, and what we have to find out, we have to find out this, that del cross del into, again within that bracket, that del dot g cap. Okay, so what is that thing? So if you carefully observe and you can refer your properties of the divergence, curl and gradient, so you will find that very first term is what? We have to find out the divergence of your given vector g. Okay, now after finding out that divergence, we have to find out what is this gradient along that respective axis for your given this bracket, and then we have to find out what? We have to find out the curl of your this bracket. Okay, so the thing is that we have to make use of the all of the three properties. So this is what is we have to find out the gradient, and this is what we have to curl of your this bracket. So the thing is that if it is not given like in this symbol form, they can simply ask you to confuse you like this one. So find out the curl of grad of divergence of your given vector. So that vector can be anyone. Now, if you carefully observe for this numerical, your whatever this given vector g is in terms of this ax, ay and az component. That means your given vector is in which system? So that is expressed in terms of the Cartesian, or you can say the rectangular system. So it is not necessary it should be always in Cartesian. It can be either in your cylindrical one, it can be in spherical system. So you just keep in mind about that properties, or you can say the respective divergence, curl and gradient of your all of the three coordinate systems, so that it will be easier for you. Okay, now we will begin with this numerical. We will find out what is its answer. Now in the very first part of this numerical, we are going to find out what is the divergence of your given vector g. So we are going to indicate it by using this del operator, del of given vector g, and what is the divergence of your rectangular system? So that is dy dx of your given vector g, magnitude of that vector g, so along x direction. So this is what gx, I am going to write it as, then dy dy of magnitude along y direction of your given vector g, and then dy dz having the magnitude of given vector g in the z direction. Okay, now we are going to put that values of respective magnitudes along x, y and z direction. So dy dx of what is the very first magnitude of that given vector g in the x direction? So we have this to be 2x square y z. So put that value over there, 2x square y z, then plus dy dy of magnitude along y direction for your given vector g. See, you might get confused over here. So this is the basic property of your divergence, that everything is given within the with this plus sign. So dy dx plus dy dy plus dy dz, and your given vector g, it is that y component is with the minus sign. So we just have to write that minus sign over there, so that you will find the correct answer. So that is what, minus 20y plus dy dz and its magnitude along the z direction. So that is what, minus x square z square. Okay, now we are going to differentiate that one with respect to x, y and z. So what is the differentiation of your very first bracket with respect to x? So that will be, this 2 will be as it is, and this x square. So x derivative of that x square is what, 2x. So this 2 into 2x. So we will find that to be the 4x, and your rest of the component will be acting as a constant, so that will be as it is, that is 4xyz. Then derivative of this second bracket with respect to y, so we will have that answer to be minus of 20, and then derivative of this second bracket with respect to z. So very first term will be 0 over here, and what about this one? So we will find that to be the minus of 2z. So this is the very first part of your numerical, that we have found what is the divergence of given vector g. Now we are going to make use of this very first answer in order to get its gradient. From the previous slide, we have found the divergence of given vector g. Now we are going to find out what? We are going to find out what is the gradient of your given vector. Sorry, not given vector. In this case, we have to find out what is the gradient of divergence of your given vector. Now we are going to find out what is its gradient. Now, what is the property of the gradient of your given vector? So here in this case, we are going to find out gradient of your divergence of vector g, which is in Cartesian or rectangular system. Now the gradient of that your rectangular system is what? Dy dx of given vector. So say for now your given vector is this given vector g having magnitude along sorry, having component along x direction. So this is how we are going to express that gradient of vector g. And here in this case we have to find out what? We have to find out gradient of divergence of vector g. So we are going to write that bracket over here. So d by dx of del dot g, that is divergence of vector g along x, then d by dy of divergence of given vector g along ay, and then we have dy dz of divergence of vector g along az. Now we are going to put that values. So we have the values for that divergence. So keep that as it is. What is the value that we have for that del dot g? So we have that del dot g equals to 4xyz minus 20 minus 2z plus d by dy of that divergence of your vector g. So again put that value to be what? 4xyz minus 20 minus 2z, and I am writing it over here. So it is in continuation with this. Okay, let me rewrite for you again so that some student may not get confused what is happening over there. Okay, so we have this to be what? D by dz of your the divergence 4xyz minus 20 minus 2z along az direction. Okay, okay, sorry, I have not written, so it should be what? There should be ax cap, and here it should be what? Ay cap. So you just note down that one. Okay, now we are going to differentiate that with respect to x, y, and z, that divergence of your given vector g. So what is the differentiation of this whole term with respect to x? So we will have that to be the 4xyz with respect to x. So we will find that to be the 4yz, since y and z are constant over there. Now this will be 0 since there is no x component. This will be again 0 since there is no x component. Along which direction? Along x direction. Then differentiation of your second bracket with respect to y will be what now? So that will be simply 4xz. So they will be acting as a constant. So 4xz are constant. Differentiation of y with respect to y is 1. Then again we will have that minus 10p to be 0 and that minus 2z to be 0 along ay direction. And what is the differentiation of third bracket with respect to z? So that will be what now? 4xy only, because differentiation of z with respect to z will be 1. So here we will have that to be the 4xy here is 4xy, then minus 20 will be 0. And what is the differentiation of this minus 2z with respect to z? So that we have that to be minus of 2. So this is what the component along z direction. Now rewrite that one, since we have found out the gradient of divergence of your given vector g, which is simply what in terms of symbol, that is del into del dot g cap. And what is that answer that we have? We have that gradient of divergence of given vector g to be 4yz ax cap plus 4xz ay cap plus 4xy minus 2 az cap. So this is the second term that we need to find out within this numerical. So we have found out what? We have found out the gradient of divergence of your given vector g. Now next thing that we are going to find out is what? We are going to find out what is its curl of this whole term. Okay, so we will see that curl of a given quantity. In the previous slide, we have found out what is the gradient of divergence of your given vector g. Now here in this case, we are going to find out what is the curl of gradient of divergence of given vector g. Since it is expressed in terms of Cartesian coordinate system, so we are going to make use of the curl of a given vector in a Cartesian system. So we have this to be what? Ax cap, determinant of this one, ax cap, ay cap, az cap, then dy, dx, dy, dy, and then dy, dz of what? So it will be what now? We are going to write what is the magnitude along x direction. So what is the magnitude along x direction? We have that to be the 4yz. What is magnitude along y direction? So we have that to be the 4xz. And what is magnitude along az direction? So we have that to be 4xy minus of 2. Okay, so we are going to write that one. We are going to find out what is its determinant in that direction. Now go on for calculation. Meantime, so what will be that magnitude? So that is equals to this ax cap will be as it is for now. Now very first bracket. So that will be what now? D by dy of this component over here. So write that one, d by dy of 4xy minus 2 minus d by dz of this 4xz plus ay cap. So that will be what now? D by dz of this 4yz, d by dz of 4yz minus d by dx of 4xy minus 2 plus plus az. So what we will be having now? D by dx of your this 4xz minus d by dy dy of that 4yz. Okay, so this is what we have now. Now we are going to simplify that one. So this is what ax cap. Now this dy of this very first term. So what we will be having now within this bracket. So left is only 4x, since now this minus dy dz of this bracket. So we will be having that value to be what? 4x again plus ay cap. Now differentiation of this bracket with respect to z. We have that value to be what? 4y. Differentiation of second bracket with respect to x again. So that will be what now? We will be having that value to be 4y plus this az, and differentiation of this bracket with respect to x. So that will be 4z, and differentiation of this bracket with respect to y. So that will be again 4z. Now if you simplify that one, you will find that whatever you is yours this curl of gradient of, sorry, gradient. I written dot product over there. It is not dot product. So given is what? We have to find out what is the curl of gradient of divergence of your given vector g, and we have that answer to be what? We have that is equals to 0. So this is our final answer. See, you might get confused in between the divergence and the gradient component. So you just practice that one. With practice, you will come to know that what is the basic difference in between the divergence and the gradient. Since they both look like same, but they are not. Gradient is what? That gradient gives you the uh, you can say the vector component in terms of ax, ay, and az for your rectangular system. And divergence gives, in case of divergence, you just have to differentiate the given components with respect to x, y, and z. Okay, you can refer this video again in order to avoid your confusion. Okay, so this is the end of your numerical. You can appreciate my efforts by hitting the like button. Thank you.